And we need a scribe. That's the nice thing about Bernard's slides. He remembers things I forget. Who can scribe for this morning's session? From now to the coffee break. Okay, Amma. Back to the agenda. When I manage to click on the right place. So before the coffee break, 2 proposals. One of which is kind of new technology. Another one is, can we make the current technology go slightly faster? After the break, 2 more proposals, or we really need to think hard about these presentations. That is Quick and Data Channel, both discussing whether we should use what WG streams. And one presentation of stuff going on elsewhere that we might want to consider, in this case, second screen. After lunch, we go back to issues. We have to get issues addressed. And we'll, if there's time on this slot, we'll also look briefly at the status of some other specs to say, any comment on these? I mean, we don't have presentations for them, so that will be ad hoc. And some more new stuff, workers and worklets, end-to-end encryption, media or Quick. So if we have need for more time on current issues, we're going to expand the 1 p.m. slot. Yuan has said that he thinks that getting the issues addressed is more important than giving him time to present his workers and workless thoughts. But we're going to get to everything, I think. And by 5:30, we're done. We're leaving. And we'll go over what's been decided and say, see you next time. Probably in cyberspace. Or in Bangkok, for those who are going there. So, let's get the show on the road.
Okay. So this is a presentation about scalable video coding extension to WebRTC 1.0. There is a document which you can look at, which is up on GitHub. Next slide. Okay, so let's talk a little bit about what we have currently in WebRTC, which is support for simulcast. The way it works is you call addTransceiver with sendEncodings. And by doing that, you can specify the number of simulcast streams and the orders of encodings, and also set parameters such as the RID, scale resolution down by, and max frame rate, and set up the simulcast. That determines the SDP that gets produced by create offer and create answer, so you have to negotiate the simulcast streams. Once you do that, you now know the codec that you've selected, and you can modify parameters using set parameters, such as scale resolution down by and max frame rate. Now, one thing to understand is those are both doubles, so they vary continuously, so any value greater than 0 can be set. So you could set, for example, a value of 3.2 for scale resolution down by, max frame rate of 7.5, etc. So encodings are described in RTC, RTP encoding parameters, and decoding is described in RTC, RTP decoding parameters, but there's not much there, just a read-only attribute RID, and that's about it. So this is just a few screenshots of the structure of send parameters. Basically, we have in there, it inherits from RTP parameters, but new things are transaction ID encodings, degradation preference, and priority. priority was moved up to send parameters from encodings because it really applies to the entire sender. So in the encoding parameters, we have the codec payload type, which we talked about yesterday, which DTX active, max bitrate, max frame rate, and scale resolution down by. And then, as I mentioned, the coding parameters only has the RID in it. For receive parameters, we have the encodings.
Remember the next slide, Bernard, because otherwise I miss.
Okay, sure. So we're on receive parameters now. So go to that slide. And nothing much to say about receive parameters except just to say that there's just the RID and the decoding parameters. So in the model we're using in WebRTC is you don't need a lot of information to decode, just to encode. Next slide. So here are a few examples of simulcasts that are in the spec. So the first one is you have a 3-layer spatial simulcast with all but the lowest one disabled. So F stands for full resolution. This, when you don't put in scale resolution down by, it's assumed to be 1.0. So that's full resolution, H is half resolution, and Q is quarter. And the second one, it's more or less the same thing where you're disabling the middle layer, but you're doing frame rate simulcast. So you're setting the max frame rate value. And here we're setting 60, 30, and 15. So think of this as frame rate simulcast. Next slide. Okay, so we're attempting to add support for scalable video coding to the model that we've already got. In terms of goals, we're looking to support temporal and spatial scalability. And that can be in any combination, temporal only, spatial only, temporal plus spatial, or potentially SVC used in combination with simulcast. For example, spatial simulcast with each stream having temporal scalability. Now, we're focused on the support for what is known as single RTP stream, single transport. That is, each of the layers in SVC uses the same SSRC. And that's how it's done in VP8, VP9, and AV1. And in most implementations of H.264 SVC also use SRST. We're trying to be compatible with the existing model in WebRTC 1.0. That means we're supporting get capabilities, set parameters, and get parameters. And one of the restrictions in WebRTC 1.0 is that by setting an attribute in RTC, RTP encoding parameters, that cannot result in the negotiation needed flag being set. So non-goals. We're not trying to support multiple RTP streams single transport. That's where each layer has a different SSRC. In practice, that's only used by a few implementations of H.264 SVC. And it only ships, that only ships in the Edge browser, not in any other browser, so I don't think we need to be concerned about it. We're not trying to have every aspect of the simulcast functionality for spatial scalability. That is to support arbitrary resolution or frame rate ratios, like temporal scalability with, say, 1 out of every 3 frames working, or spatial scaling ratios of 7.5. One reason that's not necessary is because if you're using high scaling ratios, spatial scalability actually doesn't provide much more benefit than spatial simulcast, where you already have that level of freedom in the current spec. So we don't feel we really need that. And the other thing that's a non-goal is support for differential protection, which is where you apply FEC or RTX to the base layer only. That's not something you can do in WebRTC 1.0 today, and we're not proposing that that feature be added. Next slide. So one question I'm sometimes asked is, how can you satisfy the requirements to not have RTP encoding parameters set negotiation needed? Our assumption is you do not need to negotiate SVC parameters in SVC. That is already true of VP8 and VP9. They have only 2 STP parameters, maxFR and maxFS. Neither one relates to SVC. And in VP8 and VP9, the decoder can decode anything that an encoder can send. So if an encoder wants to send SVC, the decoder can automatically decode it. And that would include VP9 spatial scalability. So there's nothing to negotiate in those codecs. The encoder can decide to send it, the decoder's just going to work. So what about AV1? Well, AV1 has profiles, but unlike H.264, support for SVC tools is required at all profile levels. So the profile level negotiation does not relate to SVC. And similarly, at any profile level, as a result of that, the AV1 decoder can decode anything an AV1 encoder can send. So we don't think it's necessary for AV1 to negotiate SVC either. So I've been asked about H.264 SVC. So there, the support for SVC, the decoder may not necessarily be able to decode everything that an encoder can send. An example is that a decoder may not support spatial scalability in H.264 SVC. There's something called the IMTC profile, which defines the scalability modes. Now, if you were to implement this, if somebody wanted to implement this in a browser, you could basically avoid the negotiation problem by just supporting decoding of spatial scalability, or just deciding that all implementations of SVC, H.264 SVC in browsers would only do temporal, and that would also satisfy the constraint that the decoder could decode anything an encoder can send. So basically, we don't think that this restriction really is going to impact the ability of somebody to support SVC in browsers and WebRTC. So here is the proposal, next slide, for scalability modes support in WebRTC 1.0. And we're proposing to add a single attribute to the RTC/RTP encoding parameters called scalability mode. It's a DOM string. We'll talk about what it means in a minute. And then to discover the capabilities of a given codec, add a sequence of DOM string scalability mode to the RTC/RTP codec capabilities. Next slide. Now, we'll talk about the scalability modes in a moment, but just think of it as a string that tells you how many spatial and temporal layers you want, and it actually tells you the relationship between the layers as well. So the pros is that this handles popular configurations easily. Just a single little string of a couple of letters tells the encoder what to do. You don't actually have to map out the dependencies between the layers, which can be a little bit complicated. It turns out also that there are some scalability relationships, which I'll show you, that cannot easily be described by these kind of dependencies. So it actually allows you to do more things than a dependency approach would, such as that in RFC 5583. You can also discover what's supported in scalability, in terms of scalability for each codec. And as you can support all the popular codecs, VP8, VP9, AV1, and H.264 SVC using this approach. The cons are that the scalability modes have predefined configurations with limited scaling ratios, like 1.5 to 1 or 2 to 1. But as I mentioned, if you want to have more extreme scaling ratios for spatial, you might as well just use spatial simulcast. You're not going to get much benefit out of SVC for that situation. The other limitation is that you can apply encoding attributes like max bitrate and max frame rate to individual layers, and you can activate and inactivate individual layers. So for example, you couldn't turn off a temporal enhancement layer, but the browser typically will do that itself. So it's not something that an application necessarily needs to manually control. And you can apply max bitrate and max frame rate to the entire SSRC, as you would do with simulcast. So you do have some level of control, not just at the highest level of detail. And that, among other things, that makes it difficult to support differential protection. But as we discussed, that's not something that's in WebRTC 1.0 right now. Next slide. Okay, so what are the scalability modes? So here is a table which is partially taken from the AV1 specification. I added L3 modes, that is, AV1 doesn't currently have scalability modes with 3 spatial layers, but I've added that in case somebody might want it. What this table means is L1, T2, and I'll show you diagrams in a minute. That's one spatial layer and two temporal layers. L2T1H, the H is for a ratio of 1.5 to 1 as opposed to 2 to 1. And so you can see in the table I have the number of temporal layers in the encoding and also whether there's interlayer dependency, and for most of them there is. In the AV1 spec, there's also S modes, but those represent simulcast, and since we already support simulcast in WebRTC 1.0, we don't need to have those scalability modes in the scalability mode proposal here. So let me show you a few of those diagrams and what they look like and how the scalability modes map. Next slide. So this slide is L1T2, and basically this is one spatial layer and two temporal layers. And so what we see here is the P1 is the first temporal enhancement layer, and that depends on the base layer, which is P0. And so you essentially predict P1 from I0 is the keyframe of the base layer, and P0 is the P-frame, which is predicted off the base layer keyframe. So this is the prediction structure of L1T2. And you can see that the temporal ratio is 2 to 1. So that is when you send both P1 and P0, you get twice the frame rate of just P0. Next slide. Next one is L1T3. And what you see here is the P2 layer, which is the second temporal enhancement. That depends on P0, like I0, which is the keyframe, or on layer P1. And so what we have here is the potential to have 3 temporal layers. And so that's L1T3. Next is L2T1. This is 2 spatial layers and 1 temporal layer. So what you see here is the S layer is predicted off of the base. So it's a spatial prediction off of the base. And then also the S frames are dependent on previous S frames as well. So they have kind of a dual dependency here. And so you get two resolutions, but only one temporal layer for each. So you can't really vary the frame rate. It's the same for both resolutions. Next slide. This is L2T2. And in this one, you get 2 spatial layers and 2 temporal. So the S0 layer is predicted off the base layer, the temporal base layer. And you also have prediction of the first temporal enhancement layer P1 off of the base layer P0. And then S1, which is the second spatial enhancement layer, is predicted off of P1. So it essentially has additional frame rate. And in addition, it is larger. It's the same resolution as S0. That's why there's only 2 temporal layers. But S1 is predicted from S0 as well as from P1. Okay, next slide. Okay, so another one is L2T3. This is a combination of 2 spatial and 3 temporal. Fairly similar to what I showed you before. Again, the S0 layer depends on the P0 base. And because it's only 2 temporal layers, S0, S1, and S2 are all the same resolution. Sorry, only 2 spatial layers, S0, S1, and S2 are the same resolution. But you can have up to 3 temporal layers. So S2 is predicted off P2 and S0 or S1. And then each of the spatial layers is predicted off of their temporal cousin. Okay, next slide. So everything I've showed you so far can be described by a dependency list, layers depending on other layers because they're regular. However, there are some things you can describe with a scalability mode structure that you cannot describe with a dependency structure. This is one example. This is what would be called L3T3. But it's not quite that way because, as you'll notice, only at the keyframe do you have the higher spatial layers predicted from lower spatial layers. So not quite the same as the previous kind of structure, not as regular. But here, the temporal is basically the same. T1 is predicted off of T0 of a given spatial given resolution, and T2 is predicted off of T0 and T1. So the temporal structure is regular as before, but the spatial structure is not. It basically only predicts spatially off the keyframe. So this is a category of structures known as KSVC. And it's, if you gave this some kind of name like KL3T3, we could support it in this proposal, whereas in dependencies kind of language, it couldn't be described. Next slide. So here's even a weirder one. It turns out in this structure, the temporal layers are offset. This is not something that is legal currently within the AV1 spec, where it's expected that all portions of a temporal unit have the same TID, but it's something that is being proposed to modify the AV1 spec. I would mention that in AV1, a structure like this, if you sent it, could be decoded because the dependencies are self-describing, but it is not currently in the mode table for AV1. And I'm showing this to you only to point out, again, the flexibility of the mode kind of a denomination as opposed to the dependency structure, where this dependency structure couldn't be distinguished from the previous one or a more regular L3, T3 kind of a structure. Next. Yeah.
So just why can you not describe this?
Well, because the dependency kind of structure, which is what we have in ORTC, only describes the relationships between the layers. The temporal relationship in this layer shifted one is basically the same, so that you could describe, but spatially, the thing here is that the HD does not depend on VGA with every frame. Only in some frames does it depend on VGA. So if you were to say that HD dependent on the VGA layer, typically in the dependency structure, that implies that that would be true at every time unit, and that is not true here. Okay. So basically, you wouldn't be able to. The dependency structure was actually created to describe much more regular structures, like the ones I showed you earlier, like L2T3, right, where the dependency is regular. Here it is not regular, and that's the problem. So you would not, as an example, ever be able to describe this within RFC 5583 kind of STP. It wouldn't be described.
I have a clarification question.
Yeah.
With all the other modes, the application is controlling what the layers below would look like. How would the application in this case describe this?
Yeah. So basically, what you would do is you'd give it a string. Like as an example, for the previous one, if you called that KL3T3, it's not. I should say this isn't in the table that I showed you, but if you called it KL3T3, and we put this in the spec, you'd say, hey, when it tells you when you have K3T3. That's what this thing means. So you basically just give it a string to identify it, and you put it in the table.
Okay, so then you would need some mechanism to write into the table new structures that we come up with.
Well, so what I would say is that would probably be kind of an IANA-like thing where the working group, it's just like stats. You would basically have to maintain some kind of table where people added modes, and you would have to keep track of what they were, so you'd have to submit like a mode and a picture of it.
Yes. Overall, it means that even though if we have irregular structures, we would have to name these irregular structures.
Yes, you'd have to name it. That's kind of a requirement for modes, is you have to have a picture and a name.
Yeah. Arun, is it more a theoretical concern or an actual?
Well, so the structures I just showed you, the irregular and the temporal shifted, are ones that are being proposed to be added to AV1. So if you didn't have the ability to somehow describe those structures, you wouldn't be able to support all of the potential AV1 encoding types. So that's one of the reasons why we think that scalability mode proposal is well, it definitely is simpler than dependencies. I can show you some example where the dependency structure gets very complex, and scalability modes is a lot simpler. But it turns out that scalability modes is actually able to describe more structures than the dependency graph can describe.
I think somewhat my concern is about the fact that if someone comes up with a new structure, they would have to go through this whole process to like actually have this control surface enabled. Whereas if we had a way to describe it in some other way, because if you could push the code already in the codec in some way, then
yeah, I mean, the reality is there aren't that many structures that are actually supported in commercial products. Like as an example, we could add lots of things to the table if people wanted to do that, but it's very rare in commercial products to see, for example, more than 3 spatial layers and say more than 3 temporal layers. That's pretty rare. I mean, I guess it can happen. We could add more modes to the table, but it's pretty rare to do that.
We did have a mailing list thread and one suggestion that we should have the encoder call out to JavaScript to decide which frame to encode next. That was rejected as probably not realistic.
Yeah. So here's an illustration, next slide, of the scalability mode approach and how you would configure various things. So one configuration which is quite popular today is 3 spatial simulcast layers plus 3 temporal layers. And so we would have RIDs in this particular situation because it's simulcast. And so you'd have the full resolution RID, and you'd put in the scalability mode L1T3, which is 1 spatial and 3 temporal. And you would put that same scalability mode designation for each of the simulcast layers. And so you get essentially 3 spatial simulcasts, so 3 SSRCs, and 3 temporal layers within each SSRC. So another configuration would be 1 spatial layer and 2 temporal layers. Here you just have a single encoding where you just say scalability mode L1T2. And if you wanted 2 spatial and 3 temporals, again, just 1 encoding saying L2T3. So you wouldn't have to describe all the dependencies in detail. Next slide.
So just in this case, in the first configuration, you would send 3 SSRCs, and in the second and third, you would say send only 1 SSRC.
Correct.
Right?
Correct. Right. 3 SSRCs in the first and 1 in the second and third. Yep. So next slide is how would you discover what the modes were supported? Well, we'll add a list of basically a sequence of the modes to RTP sender.get capabilities. So we have a scalability modes attribute which contains that sequence. And in this case, this is an example where, for example, VP8 that implementation could support encoding of up to 3 temporal layers. VP8 can actually decode up to 5, but in this case, we'd have an encoder that can only encode 3. And here we have VP9, and the assumption is that this encoder in VP9 can do up to 2 spatial layers and 3 temporal layers in either the 2-to-1 ratio or the 1.5-to-1 ratio. And then we'd have H.264. In this case, because it represents H.264 AVC, there's no scalability mode support at all because it's not an SVC codec. So this one would have no scalability mode attribute in its dictionary. Next slide. Okay, so let's talk about the basic operation, how this thing would work. So you would call addTransceiver with sendEncodings. And since we assume that SVC is not negotiated in SDP, that doesn't have any effect on create offer, create answer. There's nothing in that SDP which reflects your desire to do SVC. Because since we're assuming the decoder can decode anything, it's purely up to the encoder to decide what to encode. Now, at the time you call addTransceiver, we don't know the sending codec yet. And so just because you didn't get an exception on addTransceiver doesn't mean the scalability modes have been applied yet. You won't know that till negotiation completes. And so as an example, you could ask for, say, 3 temporal layers, and it turns out that you negotiate H.264, which doesn't support temporal layers, and in that case, you wouldn't have temporal scalability. But if you cared, you could use set codec preferences to select codecs supporting the modes you want. So you could take out H.264 and have VP8, VP9, and AV1, all of which support temporal scalability. So as long as you were able to successfully negotiate a codec among that set, you would be able to get the scalability mode you wanted. And then after the negotiation is done, you can call getParameters to make sure that you got what you wanted. Next slide. So then the other thing you can do is use setParameters to modify or set the scalability modes. So at the point where you'd call setParameters, which is after the negotiation is concluded, you know the sending codec. So you know, for example, hey, we negotiated VP9. I asked for spatial scalability. Let's see if I got it. And then you call getParameters, and you should get back a scalability mode of, say, L2, T3, something like that, which reflected what you asked for.
Bernard, I have a clarification.
Yeah.
Is there a way to say I prefer L2, T3 over L2, T2?
We don't have that here. So we're not providing a list of modes because we're basically assuming that it's a choice that the encoder can make. And if you can get the capabilities from calling get capabilities, so you know that your encoder can do it before you set it. And since it doesn't, we assume the decoder can decode anything. There's really no choice to make here. You just, if you have a codec that can do L2, T3, you can just set it to that, and as long as that codec is negotiated, it's going to work. Yeah, this isn't. We're trying to make this simple, and because we believe we can assume that there's no negotiation, you don't have to have complex offer answer going on here and say do this or do that. If you can't do this, you can just ask for what you want and get it.
Well, if it does turn out that we need that all of them are not supported, if they're all expressed with this string, it would be very easy to negotiate. But hopefully we don't need that.
Well, the problem with that is if that was true, then you couldn't use encoding parameters at all, right? Because then you would cause net negotiation needed. So you can't go down that negotiation road, or it becomes we'd have to start defining SDP, and as I mentioned, you can't even describe these structures in SDP, so it would be a whole effort to create a new way to describe them, and you'd have all kinds of very complicated things. So basically, you'd never. The industry tried to do this for about 7 years and failed. So we don't want to try to redo that effort. It would never conclude.
If you announce all your capabilities, the other endpoint would know without having to renegotiate which parameters would succeed.
Well, you know that there's nothing, as I mentioned, you can certainly do that along with the as part of the exchange, because we have the capabilities. But again, it would still depend. You'd still have to do the codec negotiation, so you don't really gain that much. And the point is that because the decoder can decode anything that the encoder can send, there's really nothing to negotiate. So if you've got VP8 on the other side, he doesn't have to tell you the modes. You already know he can decode anything. There's nothing that the sender has to take into account in that case.
I meant if there was some edge case like with H.264.
Yeah, for H.264, that is a weird case where there would the decoder could announce that it can't do everything. But H.264 is also complicated because WebRTC it could require the exchange of SPROP parameters, which isn't supported in any implementation of WebRTC, to announce the modes and negotiate stuff. So, and also for H.264, you'd have to support H.264 SVC, which no browser currently does. Like I said, actually, Microsoft is the only vendor that supports H.264 SVC. So the simplest thing in that case would be, again, to make sure that within a selected set of things that the decoder could decode anything the encoder can send. Like you could say, we can decode up to 5 temporal layers in our implementation, and you could send up to that. So basically, there are ways to get rid of the whole SDP negotiation problem, pretty much, and that's basically what we're asking people to do, is don't go down the same road we used to have in SVC, where you had this very complicated negotiation.
Are we mandating that before we add any of these supports to H.264, that anyone has to be able to decode them then?
Well, again, H.264 AVC doesn't even support SVC, so that wouldn't be a burden on any existing implementations. It would only, this question would only come up if somebody wanted to ship H.264 SVC. Like I said, Edge is currently the only browser that does that, and we use MRST anyway, so it wouldn't be supported in this kind of a mode. Basically, the industry as a whole is very focused on AV1, but like I said, you could make it work with SVC. You would just have to you would probably do something simple like just support temporal scalability along with spatial simulcast. And if you did that and just announce, say, 3 temporal layers, you wouldn't necessarily have to negotiate anything in SDP because there'd be nothing to negotiate. Just make your encoder and decoder have the same capabilities and you're done.
Right, but what if Edge does it, but Firefox doesn't?
So adding more codecs to negotiating codecs that doesn't exist requires negotiating new codecs. I suggest that the H.264 SVC is a new codec.
Okay.
So I suggest that we burn down that bridge when it comes to it.
Yeah, that bridge is already burned down, actually. Like I say, it's supported today, but nobody else supports it, so there's no negotiation that's going to happen. Okay, so that's basically how this works. Oh, I should say, let's talk about. So setParameters is used once you've negotiated the codec. So at that point, if you try to set a scalability mode that's not supported, that's not in the capabilities, you're going to get an error. Whereas and I mentioned in addTransceiver, you'll only get an error if the mode is not one that's supported by any codec. But it's possible that you could ask for a mode that might not be supported by the codec you end up negotiating, and then you just have to do get parameters and figure out if it worked or not. Okay. So this is the proposal, and there are a couple of decisions for the working group to make. Basically, the working group can decide to adopt this as a work item, or potentially you could leave it to WebRTC, which uses the dependency mechanism. It is in use. Like I said, it's going to have some issues with supporting everything that's in AV1, but it is in use today and supports VP8 and VP9 and H.264 SVC. And it's also a little bit complicated. Developers aren't that happy with it, particularly for some of the larger modes. It's a lot of stuff to put in, and people often make errors. And in addition, the scalability ratios may not be feasible. They put stuff in, and then they get an error, and they can't figure out what they did wrong. And the last alternative would be just, hey, let SVC support remain proprietary as it is today. Leave it up to the implementation and see what happens. And it wouldn't, and potentially non-interoperable.
So I have another question for the modes. I noticed there were the H modes. Can a codec move between non-H mode to an H mode during the bit stream? Like some frames are H mode and some of them without?
Well, H mode is just a ratio of 1.5 to 1 versus 2. So basically in the proposal, I'm allowing setParameters to change the mode. So for example, I mean, this would probably look a little weird to the user, but you could move from like L2T3 to L2T3H. That I don't know that I don't think that would generally be pretty jarring to the user, so I don't know that makes sense. But you could conceivably do that.
Yeah. So my question is, should we kind of forbid some of these things from happening, or not?
Well, the problem is, the reason why I wouldn't forbid it is that I mentioned that addTransceiver, you may not necessarily get what you asked for. So so as a weird example, say you asked for, you really wanted to do spatial, but you didn't know that you could get it. So for example, you would like to have VP9 or AV1 negotiated. So you put in like L2T3, which is spatial. And then it turned out that the system you were negotiating with only did VP8. So you didn't get anything, right? And then you could want to go into set parameters and say, well, since I got VP8, I'd at least like to do, well, you've actually got a problem there, because typically what you'd want to use as a substitute is like spatial scalability plus temporal. But because you've already set the simulcast envelope, you're stuck. So the best you could do would be like one stream with temporal, or you could just reset and do another offer answer, this time for like spatial scalability, spatial simulcast with temporal. And the other side had VP8, and that would actually conclude successfully. So they're basically, if you don't allow set parameters to change the mode, there could be some failure conditions you wouldn't be able to recover from, and you'd have to do another offer answer.
Yeah, so I guess what you're suggesting is first do a blanket negotiation, see what gets accepted on the other side, then figure out what modes you want after the codec.
Well, actually, what might happen is you might, and this is a very popular thing, you might just do spatial simulcast, which works with all codecs, and then temporal in addition, which might not be supported by all codecs, like it isn't supported by H.264 SVC, ABC, sorry. So, but you'd end up getting something reasonable for all codecs in that case. Like if you negotiated H.264 ABC, you'd end up with 3 spatial layers and no temporal, but that's the best you can do. So that would probably be okay. So that might be one simple way of kind of dealing with it, is just to ask for a configuration that's very likely to succeed, or at least give you the best fallback.
Right, so that would be L1T2, L1T3.
Well, you'd ask for that would be the configuration. The example. Where did I have that? So it's this. That would be this example where I'd ask for this three layers of that. Go to the scalability mode example, Harold. Slide 25. Basically, you could ask for this 3-layer spatial simulcast plus 3 temporal layers, and that would either give you that for VP8, VP9, and AV1. You'd either potentially get that, or you would end up with 3 spatial simulcast layers with H.264, which would probably be the best you could do. So this would probably be a very popular choice.
Yeah. So then the question is, why standardize this?
Well, you might want something else, right?
Yeah, but if the popular and the most often choice would be step 1, which is L1T3.
Well, you might, in particular, you might want spatial scalability. I mean, that's why if you have AV1 codec, right, that it has that feature, it can't be exploited today at all. And in addition, you can't select, any of the other KB SVC modes either. So.
I don't know, from the offer answer perspective, it doesn't seem to solve our problem, because it seems that the best way to do this would be 2 offer answers.
No, there isn't. You don't need any offer answers at all. I mean, basically, in most situations, you know what codec you're going to get. The only uncertainty created here is because of H.264 ABC, which doesn't support SVC at all. So. Yeah, it would be very rare to do 2 offer answers. That probably wouldn't happen. Probably what might happen is you might do 1 offer answer followed by set parameters, which is why you need to be able to change it with set parameters.
Okay.
So would set parameters be good enough then, and not add any?
Well, it wouldn't be good enough, because if you don't have addTransceiver, then you don't start out with scalability, right? And you wouldn't have any simulcast, so you basically would have potentially nothing. And since you can't change the simulcast envelope, then you'd be stuck.
Yeah, I'm just talking about removing scalability mode attribute from.
Yeah, you basically have to turn it on later, and so you'd start off the session with no temporal and no spatial.
So are you suggesting that set parameters with scalability mode should only be allowed after negotiation?
Well, you don't know the codec, so you can't really, before negotiation, so you can't really call set parameters.
Well, you call set parameters before negotiation all the time to set it, I think. I don't think we have a general.
It seems a little bit weird at the moment to me. But
I don't think we have a general rule that says that you can't call setParameters before negotiation. But yes, we would have more ways to fail.
I would have thought the setParameters before negotiation is what you want to use, but then it might not be applied. And then after negotiation, you pass or fail based on knowing what you've negotiated.
So the whole thing about when setParameters can be called might be an interesting issue to raise.
Yeah, I think we're not all that sure about it.
Right. Like, is there any difference between doing addTransceiver and doing some parameters and doing the addTrack followed by?
There is, at least if you look at the setParameters, you can't change the simulcast envelope. You can only do that in addTransceiver. So there actually is a difference, at least the way the spec is currently written.
So it seems like the better strategy would always be to like do the simulcast to the SVC, and then once you have everything figured out, then figure out you're not going to do simulcast and do layered L3 T3, because now you actually see the other side can do L3 T3.
Yeah, you could certainly do that because you can always inactivate simulcast layers. You just can't add to them. So yeah, that would be one way to do it, is you set the simulcast stuff and then figure out the temporal.
Yeah, I don't know if you're making it easier for developers or making it difficult now, because you do simulcast and you do SVC, and then later on decide if you want to like decide.
No, I mean, like I said, you can set it up all at once if you want to. And there's no complicated two-layer thing here. You can the only complexity comes if you negotiate a codec with no SVC support at all. Then you've got a problem. But today, remember, there are some cases codecs that don't even support simulcast. So we've already got this issue with WebRTC 1.0, right? Not every codec supports simulcast.
So I would imagine that most people would do FHQ all the time and see later if they negotiated a codec that can do L3 T3, then basically remove H and Q and then just set F to be L3 T3.
You can't remove it, but you can inactivate it.
Yeah.
Why can't you remove it?
Because you can't change the number of layers and setParameters.
And why not?
We prohibited it.
Why?
It's basically what it says. You set the envelope in addTransceiver. That's currently how the spec reads.
Because it's a mess trying to increase it. So we just said that what you have is what you have. If you want to transmit only one, then you can turn off the other layers.
Yeah, just make it just to set active false.
Reducing the number of layers would be a promise to never turn them on again. Which
also remember the reason you can't do it is because you can't encoding parameters can't set negotiation needed, and if you change the number of layers, you do need to negotiate an SCP, because the simulcast layers are expressed in SCP. The SVC layers are not. That's why it can't be done. It basically would set negotiation needed.
Get into like infinite loop.
Yeah.
Okay.
So back to SVC. We have decisions to make. So there are 3 options on the table for adopting this document. It's adopt this draft as a starting point for a working group effort. There is reject this draft as a starting point for a working group effort, but keep the option of doing it. And the third one is burn to the ground, which is say that SVC should forever be out of scope. I have heard nobody arguing for the last one, but in theory it is an option. So does anyone want to make an argument for making one or the other of these 3 decisions?
Yeah, with UN. So first, I think that compared to the initial proposal, this one is hitting a sweet spot in terms of complexity and expressibility. So it's nice to see improvements. Now speaking, so the overall direction and makes sense, and so I'm not opposing to that and continuing making improvements there. In terms of WebRTC working group work item, I think that we have a lot of things to do before that, and any new work item will add to the plate, and we know the plate is very full, and so we need to eat the plate first. So
well, the problem is SVC is going into WebRTC this calendar year, and so if you don't standardize it, it's just gonna ship, and then you'll be done. There won't be any point in standardizing it. It'll be proprietary forever. So you put it off, it'll get into products, and then you'll just have to, you know, reverse engineer it. That's it, because it's going to ship this year. Because AV1 does require this.
We do have the option of not taking it up as a working group item and saying leave it for later, but that will probably leave us in a situation where the only viable alternative is to ship whatever the first to market implemented.
And if I understand correctly, the only control service is adding the scalability mode and the associated JSON or dictionary tool.
Yes.
Right.
So there were some announcement made yesterday saying that there will be a WebRTC 1.0 implementation next year, that things will be much improved in terms of simulcast in January and March. But at the same time, it's what's acknowledged that simulcast is a mountain that we haven't measured yet, which is a potential issue. So until we fix that, I'm not convinced we should take time within the WebRTC working group. That does not mean that I'm happy to provide feedback. I'm happy that the document evolved somewhere, and I'm happy that maybe in January or March we can revise this.
Well, the problem is, like I said, March is when AV1 will have completed the RTP encapsulation, which will basically require, it'll need to be tested. So, you know, we won't be able to fool around with the spec at that point. It'll be in code. So it basically will, you know, there won't be any point in coming to this working group. So it'll just evolve independently and be a proprietary feature of WebRTC 1.0.
Okay, Alex here. I'm wondering if simulcast and SVC are already so far apart that we cannot do them with the same task force. It looks like the people that we mentioned and that would be volunteering to help for simulcast are doing actually SVC at the same time.
Right.
That might happen. We're also working on SVC and AV1 separately at Cosmos. So Sergio is volunteering some time to work on SVC if need be, and that way that would not delay the other task, right? So we can have additional people take care of that. That's also one possibility. But I agree with Bernard. On the 27th of September, the Yahoo Media just reviewed the proposal for the RTP encapsulation of AV1. And so that thing is going to come, and we should work with them right now.
I'm not arguing against the idea that there will be work and things done there. It's just a matter of where it will happen, and in a matter of priorities of this working group. And this working group delayed a lot features, delayed a lot getting the WebRTC 1.0 to a level of pain which is bearable by web developers. And web developers are still suffering. Implementers are doing great improvements, but still we need to fix those issues. We spent quite some time, and it's great to see these new ideas coming. But we spent some time discussing those, and that means that we are eating time to some existing issues in shipping software. Maybe next year there will be 3 WebRTC 1.0 full implementations with also shipping SVC support. but will it happen? I don't know. So
now SVC support's been shipping for 2 years, 3 years. SVC is already done. That's not a question here. SVC is in the wild. It's already shipping. The only question is whether it'll be proprietary.
So Bernard, you said it's shipping, or it will be shipping, and whether it will be proprietary or not. Can we get a deployment plan where we leave space for improvement, and not as we've suffered through WebRTC, where we deploy stuff, break stuff, come back later, and so on? And I guess one of the model of synchronous development in the past couple of years has been how CSS Grid was basically almost synchronously released across browsers to great effect. And of course, CSS is a very different beast, but if we could make it so that for this type of new WebRTC, we would get less of a race to first to the market, but instead get more experimentation, a well-defined framework.
Yeah, the problem is that some API is needed for AO Media to test the AV1 code. So basically, if we put in the API, if WebRTC doesn't want to do the API, it'll get done in AO Media and will never be done in WebRTC working group. There's just no need, right? Because if AO Media already standardizes the API, why do they need to come back to the W3C and change it? It'll just be done.
You mean it would be in-band, right? So basically, you just
it would be in the native code, and AO Media can actually standardize the API there, ship it in the source code, and then it'll just be reflected in JavaScript, right? So this would just it'll just go to another SDO. That's all. And so there'd be no point in bringing it back here because it would already be standardized in another SDO and already shipped. So there'd be nothing for the W3C to do. That's basically what you're saying. You have a choice of doing it here or doing it there.
So the counterpoint to Yuan's argument is that the people doing SVC will do the same amount of work, and we have the choice of them doing it as part of the working group or doing it elsewhere. Having them as part of the working group will ensure that they actually spend some time communicating with the working group. It does not necessarily mean that they will, if they don't communicate with the working group, it's unlikely that they will contribute to other working group items. This is one way of thinking about it. I could argue both sides of that issue, but I'm somewhat afraid of saying extensions should go elsewhere because we're so busy polishing the last thirds of 1.0.
I'm not arguing against that. I was hoping that we would end up with a very concrete plan about how to go to WebRTC 1 PR, and we are not yet there because we are not able to measure how much simulcast will delay us. That's life. I'm also hearing that the same argument for other items that we would like to add in this WebRTC working group, like Quick. So if we add more and more extensions, given the time of the chairs and the few people that are active, maybe there will be more, but I'm afraid it might not all be the case. We have some interim meetings, the time is counted there. So if we add more stuff, we will need to talk in these meetings for various items. And it will, of course, delay WebRTC 1.
I'm not sure why that would be true.
That's about the of course part of that.
And just as a person who cares about stats a little bit, I think the spec currently, as it's written, is not just the change here, but it also requires substantial work in the stats part, which has not yet found its way. both for simulcast and for SVC, because I think that's where a lot of the work needs to be done. So I think there needs a lot more energy to get this somewhere. But I'm not opposed in any way to make this a work item.
It's hard for me to assess the how much work this is, because I don't know the details. But in terms of the spec work, the proposal seems fairly simplified. Like we have these different modes. I don't know how much more is or how many issues. Like, if is this a can of worms, or do we just land this? Can't really assess this.
Yeah, I mean, many of the issues we just talked about were also in simulcast. So, I mean, I don't know how many issues you could have. We talked about set parameters and versus addTransceiver. That's not a huge conversation.
It does seem like a benefit that we have to deal with simulcast already. So, for things like measuring throughput and things you would do for stats, it would come down to if there are any, what's the difference in tracking stats for simulcast versus SVC. So is there?
And since we're SVC is already shipping, right? So, we just haven't basically standardized it. So it's a proprietary thing. It isn't like it doesn't exist. It's
so just going back to the stats. In the simulcast, the layers are separate. They're on different SSRCs, so it's easier. Within this, the layers are within an SSRC, and we haven't actually cracked that part of it. That means that you have like a layer inversion problem where you need to have stats inside an SSRC, which are going to tell you like what the layers did. While in the simulcast case, you just say there are these 3 SSRCs and you figure out what the stats are. So yeah, I don't think it's non-trivial or difficult, but I think it requires some effort to just walk through what we need.
Also, simulcast, Bernard, you tried to move it in an extension spec, and basically this would be an extension to the simulcast spec. So, but at some point we might say, hey, yeah, let's put it in WebRTC 1.0 because it's much easier, and probably it's much easier to add it to WebRTC 1.0. And if we were in a living standard, it would make sense, and probably it should be offered this way within WebRTC 1.0 as a parameter. But since we want to finish, I doubt that we want this for WebRTC 1.0, right? Because PR is very close now.
No, it's an extension spec because it's not part of WebRTC 1.0.
Exactly.
That's the whole point. It's not in WebRTC 1.0.
I don't really know what the difference is between doing this work in ORTC and doing this work in a WebRTC working group, for instance.
There's no work done in ORTC. It's already shipped. It's just that you have to use ORTC to get it. And it doesn't satisfy the AV1 requirements because it can't handle every mode.
So what I understood was with ORTC, it's not this proposal, right? It's a more complex.
No, it's much more complex one.
Yeah. So, but within ORTC, you can also do that work of saying, "Hey, this is the extension spec, and we are."
No, it wouldn't happen. Basically, ORTC is already done, so it's just going to ship. It's already shipped, right? So there's no point in modifying it a lot. It is what it is.
So let's do what we call the straw poll. And so I get the impression that we have do now based on this proposal. Don't adopt this now. Put it later. Never do this. Now, going through this in reverse order, who thinks we should never do this? I see no support from that. Who thinks we should not do it now, but do it later? Who thinks we should adopt this now?
Yeah.
I'm sorry, Johan. You're in the rough.
Yeah. I like this to go to the mailing list, and I like to discuss this internally because before there's a decision.
Okay, so I'll note the decision that we will adopt this document now, but we will verify the decision on the mailing list.
Is it a matter of a week, really, to adopt this so that it ships in 2 weeks?
It'll take a couple of weeks before we can call consensus on this. Okay. Next presentation. Now I start talking. Since I can only see my own screen by watching the screen, I'll have to give this presentation with my back turned. Sorry about that. So the presentation is really short, I hope. Problem. People want processing of audio. I picked audio for this particular one because, well, it's easier to deal with than video. As we saw yesterday, video has its own problems. There are many reasons for that. Some are inline. They take audio, process it, then spit out audio again. Some are doing processing on audio and doing stuff to it, but not emitting it again. Like they're transcribing it, or they're just showing a volume meter or whatever. What they all need is low overhead, reliable delivery of the samples, and minimum delay. For some, minimum is more minimum than others. We have an existing solution that people have used in many places in the environment, which is based on web audio. We connect the web audio to a media stream track or a media stream track to a web audio context. Both ways work. And then we run a script processor node, which is for every bunch of samples that come along, run this piece of JavaScript on it. This has been deprecated by the web audio working group. By the way, are there anyone present here who is active in the web audio working group? I was afraid not. So so we still have to talk to them. So they've deprecated that one and prefer that we should use something called the audio worklet, which is you do exactly the same thing except that it runs off the main JavaScript thread, which means that it's in a different JavaScript context and runs in an environment that has no access to your page. But it's possible to send messages back and forth. I've actually made the messages work in one direction. So the link on the slide is to a very, very, very simple demo done using my enormous skills in making HTML look ugly, which simply runs an audio worklet and sends a message back to the main page every few samples that says, okay, I measured the volume to be this. Should be relatively minimum overhead. So what happens when you run this system, as far as I have been able to read the specs, is that you convert the samples from the WebRTC representation into Web Audio's favored representations, which is a float 32 array. And then you synchronize to the clock that the Web Audio context uses. And then you pass the samples to this worklet, take the output, and then synchronize it out to whatever sound sync that is connected to the audio context. An interesting thing is that that with running the demo was that you have to put the output somewhere. You can't have something that has no output, which might be account for the surprising results I got, which was that this seemingly simple process ate 25% of one of my CPUs. So there's no overhead to it. So I wrote up an alternate proposal, which was, okay, let's not touch audio context. Let's do something independent. I kind of have in my head how I can connect this API down to the C++ API of the WebRTC audio implementation, which is then not touching anything, possibly not touching anything at all outside of the WebRTC context, and might not be synchronized. So it's a fairly simple interface. It basically says, yes, you construct something, giving it an input, and then there's a function called process that is called every now and then to chew up your samples. And I chose to make it possible to have multiple formats of the samples, so that no matter what the sample format actually was, it could process it. Just to say that, make it possible to do as minimal processing as possible. I figured out that, yes, this can be done in a way that I can write a small shim and put it on top of audio worklet. So anything that implements audio worklet can also offer this interface via shimming, which is good for prototyping. Of course, putting it on top of audio worklet doesn't give you anything that is able to work without audio worklet, which was kind of the point, which means that it's only useful. That's a property that's only useful for shimming, as all shims. There are a couple of open design issues in the proposal I made, which is, do we process one track at a time or multiple tracks inside a single worklet? We could have multiple worklets, each processing one track, and then coordinate between them with using shared array buffers. That's a rather complex way of doing things. We could also redesign the API to have multiple tracks connected to a single worklet with independent processing of each track, which has the advantage that you don't have to synchronize, but doesn't. But otherwise works fine.
So a question, Harold, how would this work with codecs that support more than one channel, like Opus Stereo?
Stereo is just a matter of how you represent the samples in the buffer. And the audio worklet actually gives you one buffer per channel. And the more common format I've seen in web audio is that you interleave the samples. So that's another conversion thing that we might be able to skip over and let the client handle it. As long as we make it clear in the API how you can tell where the samples go, I think lowering the overhead is important. Of course, the list of formats that you need to support should be finite. Like 2 is probably something most writers of audio processors can handle. 500 would be overkill. And infinite number of things cannot only be supported by the infinite monkeys. So But before we get to that, or it might be dependent, we have to make a no-go decision, which is, does designing a new API offer enough advantages over web audio that we should do it? Or should we say, go over to the web audio group and say, can you please fix your overhead problems? So, do we have a story that tells us that giving a new API to raw audio samples is compelling enough that we should add a new API? Yes or no?
So the question might be, are there use cases, new use cases that web audio couldn't cover? For instance, do you know that?
I know that the case where you have things coming off an unsynchronized clock, and you want to do the adaptation to the local clock based on your own algorithm instead of depending on whatever the system algorithm is. That you can't do that with web audio because it's already synchronized for you. That's the only case I know that web audio wouldn't be able to support without a redesign. I don't know if that's an important use case or not.
Well, there are a number of use cases in machine learning which require substantial processing power. So I am concerned about what you showed, the level of overhead in web audio. I'm not saying they can't be done, but I'm not sure they can be done based on what you've showed with the level of overhead.
So what we learned from yesterday was for video that GC was the issue. So for audio, GC might also be an issue if you need to copy each sample in some JavaScript arrays and do processing in JavaScript. So if you want to go there, it seems that you will also need WASM integration for that proposal. So if web audio is addressing that in the audio worklet, for instance, we will learn a lot from them. So I definitely think we should get the feedback from the web audio working group. I cannot judge whether web audio will be able to solve all the issues that we have there, either now or in the future. So we should have web audio experts say, yeah, go for it, because we will not be able to solve this with web audio.
The Ning-Chin's presentations yesterday told me that there were two issues. One is the sheer amount of data that needs copying. That's his red line. And the other one is that if you use new and if you create buffers and discard them continuously, the garbage collector will bite you in the butt. I think we can avoid the latter one, and it helps that it's in a separate JavaScript context, so that the audio worklet is not hit by the garbage collector on the main thread. So all you have to do is to make sure you make sane use of buffers inside the audio worklet.
Well, I think you have enough to file issues on web audio to make sure that they see if they can fix our issues. I agree that garbage collection would be the main issue, and we have a whole working group working and dedicated to that. So I'm still interested to see how they end up solving it and if that can be improved. So I think it's premature to say that this working group is going to take on that task and do it better than the web audio group.
Use the mic, or Bernard would not hear you.
Is that 25% overhead number that you were showing? Is that primarily due to GC, or is that due to other processing that's happening with web audio?
I filed I mentioned it to people working on web audio in Chrome, and they told me that it might be a specific Linux problem. So if anyone with a Mac can bring up the presentation and click the link and tell me what overhead they're measuring, that would be nice.
How do you measure overhead?
That's a good question. I use top. So I was purely guesstimating, as in this process is running 25% hotter when I run the demo than when I'm not running it.
Yeah, my guess is they probably is that the GC isn't getting invoked while you're running it, because that would seem to be very strange to invoke the GC in the middle of a process. So I mean, I think we're kind of, you've raised an issue that web audio is heavy on the processor, but I think there's another issue being raised in that we have the GC issue and a lot of memory related aspects related to that, memory management aspects. So I think those are two different.
Yeah, but Harold's demo doesn't really use a lot of memory.
Yeah, so then I don't think why. I think it's probably due to inefficient web audio implementation, not so much garbage.
If we can reuse buffers, I don't think the GC would be a problem.
So I would be very happy if someone can run that demo on something that's not Linux, because I'm personally running only Linux machines, so I have a trouble measuring on anything else. And Linux is a minority platform. It's not optimized like the others.
So just running it on a Mac on Chrome, it says 8% and 45 MB footprint, memory footprint, and I don't know what units. Do you guys know what this unit is? For CPU 7.48. But it was, without the tab, was 0.
It was what?
It was 0 before, and it's the large.
Right
now
percent?
I have no idea. You guys should know. It's your.
So 8% of a CPU or something?
It's a Chrome's task manager. It's the inbuilt.
Probably percent.
So it's significant, but not as big as on Linux.
I don't know if they're comparable units, but
yeah. So that's
yeah. For me, I'm using top, and it's fluctuating quite a bit. But usually it's 10% of the CPU that is marked in top. I don't know if that means anything, but
so that's not ballpark same thing. So I'm hearing that before we take any decisions, we need input from web audio folks.
But if we would, this seems like you could, if you can do this for audio, you could do it for video, and you would want the API to be similar. So in this case, maybe you can survive the copies. Although, I mean, that's a large percentage. Maybe like they would have to optimize. I think if you want to do something interesting in WebAssembly with the audio. But if you're doing it with video, then you definitely want to avoid the frame copies and things like that. And I'm wondering if that's is it possible to have an interface where we are reading and writing directly to a buffer shared with the processor, and
shared array buffer
shared with the processor and the thing producing the stream.
Well,
there's a slight problem with WebAssembly and shared array buffers, in that WebAssembly's model is that you can't see anything outside of the WebAssembly memory footprint. There's work going on in the WebAssembly working groups to be able to see shared array buffers exactly for this reason. But I don't think that's out yet. So we can probably get it down to 2 copies by careful API design.
Audio and video are also a bit different. Like for video, you will try to do WebGL, WebGPU to use as much parallelism as you can. For audio, it's more difficult to obviously to do this kind of parallelism. So in that case, WASM might be good enough. But for video, I guess, yeah, we would like to go to GPUs and so on, which might require different integration at GS level as well.
Yeah, just to kind of follow up on that, I think from a specification perspective, you might be limited in the relief that we can get from the web audio team because of similar reason. I think we, at least within my organization and Qualcomm, we've looked at before how to hardware optimize web audio using our existing using the existing hardware optimized platform multimedia technologies such as Chronos, OpenNext, and such, and we didn't run into good solutions on that. So I think if web audio was majorly re-architected to actually better take advantage of hardware accelerators and the various different computing platforms out there, whether it be smartphones or PCs, then you might actually be able to solve some of the problems. But I think going back and trying to tweak the API surface is probably not going to be the answer.
No, it's so you're saying that you see an advantage in making an audio path that does not touch web audio?
I think it has to be yeah, basically it would be something that would offload onto the existing multimedia processors, whether it be in the graphics case GPU, and avoiding all the and trying to move a lot of the memory management issues over there and out of the browser, or in the case of audio, it would be audio DSPs that you find a lot on at least on smartphone and tablet devices.
Okay, so the action items I'm taking off this is go talk to web audio folks and report back to the group what they say. We do not stop this this item at this time, but we also have not made a decision to drop it.
Also, Harold, I think the machine learning CG might be very interested in this problem.
Yes, their machine learning folks are primary users of this kind of APIs. So I'm recording as an item to take to talk to the machine learning CG about what APIs they need for audio and video. That should fit to the requirement spec. Bernard, do you talk to the machine learning folks?
Well, I know some of them. I mean, I haven't. The CG just got formed, I think, at this TPAC. So they just, I don't know when they're meeting, later in the week, I think.
Okay, so Ninjin tells me that they're meeting on Friday. Who's here on Friday and can take an action item to go talk to them? I mean, you're obviously here. Yep. Any WebRTC folks going there? We'll see. Okay, we'll consult or email at least. I'm not here. Sorry. Now I have eaten 15 minutes of your breaks. Press. Let's get back here at 10:30. Time for coffee.